Namaste. Welcome to tutorial series on SuperPro Designer for beginners, a step-by-step guide to process simulation. In this video, let us see how to perform a simple energy balance on heat exchanger, and the problem statement is as follows. A shell and tube heat exchanger is used to cool hot water with cold water. Hot water enters through the tube side of a heat exchanger with a mass flow rate of 0.03 kg per second and 80 degrees centigrade, cooled to 30 degrees centigrade. Cold water in the shell side flows with a mass flow rate of 0.06 kg per second at a temperature of 20 degrees centigrade. Determine the outlet temperature of cold water. So all the details are given. So according to this problem statement, hot water enters through the tube side and cold water enters through the shell side. And three temperatures are given, that is hot water inlet temperature is given, hot water outlet temperature is given, and also the cold water inlet temperature is given, as well as the flow rates of hot water and cold water is given. Basically, from this problem statement, we understand that water is the only pure component which involved in this simulation. And as we already know from our previous videos, water by default is registered as one of the pure component. If you go to this register pure components, and we can notice water is already available. We no need to register them, register that particular compound again. Click OK. So let us select the equipment, go to unit procedure, go to heat exchanger, and here there is an option called heat exchanging. You can select this heat exchanging, and if you could notice here, this white color arrow marks, you can notice it's a shell side, and dark one, it is nothing but your tube side of a heat exchanger. Let us connect them. So first let us select this shell side equipment and shell side outlet, and we select the tube side, that is, yes, this is tube side, and we will just rename it. This is tube, or else we can also rename it in such a way that is tube in, or else we can also mention in the tube side it is hot water in, hot also water in. Click OK, and this is hot water out, and you can mention here that shell in bracket you can mention cold in, and this is cold out. So for our easy understanding, so we can rename them. Click OK. This is shell side where cold water is entering, the tube side where hot water is entering. Now let us initiate the operations. So no need to add any operation, it's a continuous operation. Click operation, and you can notice that we go with counter current operation. All the default values we go with, but before that let us initiate the streams. To initiate the stream, let us go with cold water, and the problem statement it says that it is again water which is available at 20 degrees centigrade, and the flow rate is also given, it is per second. First let us select the second, and we mention it as 0.06 kg per second. So click OK. Temperature we set it to 20 degrees centigrade. Click OK. You can notice it is reflecting here, and also tube side, tube side again hot water which is available at 80 degrees centigrade, and flow rate per second, and the flow rate is given is 0.03 kg per second. Click OK. We initiated the input stream, and we go back to the operation, and there are like target, the performance option. In this, multiple options are available: minimum temperature approach, hot water, hot stream temperature decrease, means how many degrees you want to decrease the temperature. But in this problem statement, already the hot stream outlet temperature is given for us, so it is easy for us to perform the material and energy balance. That is given is 30 degrees centigrade. I'll just select 30 degrees centigrade. Let all the other parameters be at the default values. If you want to change, do the pressure drop changes also, if whenever you use some gaseous streams and all, you can also work out this pressure drop values also. Now we go with the default value, click OK and perform the energy balance. Now we need to understand what is the cold water outlet temperature. Double click on this and you can notice the cold water outlet temperature is 45 degrees centigrade. So it is showing in kg per batch. Let us go with kg per second. Click on that. So you can notice 0.06. So whatever it's entering, it is coming out. It's like a steady state balance. Nothing is accumulating inside. And you can even do the manual calculations or manual balance, that is Q is equal to UA delta T or general mass balance or MCP delta T. Such equations you can employ, and you can equate how much heat is kind of transferred from hot water to cold water. Just balance it and you can also calculate the outlet temperature. So I hope you understood how to perform a simple energy balance using SuperPro Designer. Thank you.